Hello, I'm Jerry Winslet along with Kenneth Ezel. And in this course, we're going to take a look at the atmospheric direct vent water heater. We're going to talk about the features and benefits, how it works, and troubleshooting. So speaking of features and benefits, why would you go with an atmospheric direct vent water heater as opposed to, say, a standard water heater?
Well, the biggest thing with the atmospheric direct vent water heater is that it uses outside combustion air.
Okay.
So if you have to install water heater in an environment where you don't have a lot of combustion air or not enough combustion air, it's a perfect water heater for it. You know, this water heater uses a concentric vent to where as the hot air rises, it pulls combustion air back through the pipe.
Yeah, I've got one right here.
Yeah, it provides that water heater with air. And so you have a 6-inch outside diameter pipe, right? You have a 3-inch inside diameter, and this comes with the water heater. This isn't a special pipe you have to go buy anywhere.
This is in the box.
Yeah, it's in the box. We provide it with it, so you must use the vent we provide with it.
Okay.
But this is going to be your exhaust vent on the inside.
Okay.
This is your intake vent on the outside. And so what happens as the hot air rises, through the water heater and everything, it's going to create a slight vacuum behind it, and it's going to pull, combustion air back through the outside vent from outdoors. So you don't have to worry about combustion air with these.
Okay. So you don't have to plug these in. It just does this automatically.
Yeah, it does it automatically just from natural draft.
Okay.
All the power this heater makes, it makes itself. We don't plug it in. It uses a thermal pile, with the electronic gas valve, and it does it all itself.
All right. Now you've got the termination right here as well.
Yes, and this is a termination that comes with the water heater. Right, so this is what you'd have sticking out of your wall, right? So this would be mounted to the wall.
Okay.
And the same thing, so that your pipe, the other end of it, one end hooks to the water heater, the other end hooks to this.
Okay.
And so this can get really hot with these water heaters, so usually you want to make sure you put a grate around it or a shield if you have small kids or someone who can touch it. But yeah, so this is your vent that's, comes with the water heater, the termination, everything you need. Now, it does require this to be sealed.
Okay.
Right? It is going to have to be sealed. So when we seal it, that end comes with O-rings.
Okay.
Right? And clamps.
Oh. Okay.
Yeah, so you have O-rings here that the vent's going to seal to. And it comes with large clamps where you clamp it. This end right here, same thing. We're going to clamp the inside piece, and then we're going to use high temp RTV, to seal the outside.
Seal it up.
You're correct.
Okay, and I know that's a pretty long exhaust and intake pipe. Now, do we cut it, or how does it?
Well, it's very versatile. That's how it comes out of the box, but it's corrugated, so you can actually pull it and make it longer.
Okay.
If you need it to be longer, or if in the rare instance that you actually need it to be shorter, you can cut it.
Okay.
The manual talks about specifically how to cut it because you have to keep one end longer. The inside pipe has to be a little bit longer than the outside. And so you want to make sure you follow what the manual says.
Okay.
The biggest thing you want to keep in mind that if you are going with a shorter vent run, the water heater does come with a restrictor.
Okay.
You want to make sure that you use a restrictor on the exhaust. That way we're not creating too much draft.
Then that restrictor, does that have to go on here before you put your
Correct.
Your
so if you're
pipe
using
on?
a short vent run, you'd use the restrictor right here. And the manual talks about the requirements for that. Sometimes you have to use it if you have a tall run right straight up off the heater. If you're going, a long vertical run off the top of it, you may be required to use the restrictor. So always check the manual for specific venting requirements.
And you would use this in a situation where, we have a limited combustion air in the room.
Correct.
We're worried about that. But a lot of times, we're just putting these in where there was a previous direct vent water heater, right?
Yeah, you would put in a retrofit application, you could put this water heater in. The only thing you want to take care of is as energy standards have changed and we've insulated the water heaters a little bit more, these heaters are a little bit taller.
Okay.
And on our horizontal vent runs, we do suggest, or it's actually a manual requirement, that you at least maintain a 1/4 inch incline on that vent run, on the horizontal vent runs per foot.
Per foot, okay.
As you go horizontal. Of course, it's not going to be that long of a vent run because you're limited.
Yeah, and really, these are really set up where it goes straight out the sidewall, right?
Correct. It's typically going to go straight out of a sidewall. So on your retrofit application, it may be necessary to actually, if the new water heater is taller, you may have to modify that opening some. So it's something you want to keep in mind.
Yeah, and all that's laid out in the manual.
Correct. It's all in the manual, all the venting requirements. So if this is a heater you're using, I'll suggest definitely brushing yourself up on
Right.
that.
And one thing I said before, we don't plug this in, so we generate our own electricity to run this gas valve.
Correct. It doesn't plug in. It's a lot like a standard atmospheric vent water heater in that regard. We're using a electronic gas valve, and we're using a thermopile, to generate our energy, which is pretty similar to a thermocouple, right? We're just generating a lot more power.
So basically, it works just like a standard atmospheric gas water heater. Once we get the air in, it's just going to create hot water just like the other, correct?
Correct. When the water's cold, right, that's going to cause the thermostat to, call for heat, which means the gas valve's going to open, dump gas to the burner.
Okay.
It's going to be ignited by pilot light. It's going to heat the air up in the combustion chamber. Hot air likes to rise.
Right.
Right. So as it rises, it's going to pull cool combustion air back through the outside of that vent, down through into this air box, which goes down a snorkel on the back of the water heater.
Okay.
Right, to provide that heater with combustion air. And so that's why it's good with this heater if you have a severe negative environment. Or if you have an application where your water heater is installed in a bedroom or bathroom, you must use a direct vent type unless you meet other very specific requirements for other types of water heaters. So it's a good water heater in that aspect. It's something that's probably not really used enough.
Right.
For people to meet the air requirements and everything, but it's that's the biggest thing is you don't have to plug it into the wall. You don't have to worry about combustion air. It's built for this.
Yeah, and if the power goes out and you still have gas, you'll still have hot water.
Correct. Yeah, it's still going to work.
Yeah, and a lot of people probably don't realize it's there because they don't take the time to look. Because usually, whenever you're replacing a water heater, you're just going to get what you had in there before.
Correct.
But sometimes you need to take the time and take a look at what's out there. We make many different water heaters.
Yeah.
So this is just one that could fit the need if you're experiencing a problem with combustion air. All right, so that's a little bit about how it works and the features and benefits. Let's talk about troubleshooting with this.
Correct.
Now, really, one call that we get is no hot water, and it's the same with this. That's the number one call on this guy too. We're not producing any hot water.
Yeah, we're not making any hot water. So a couple of things you want to check, and that's missed sometimes, is making sure the water here is actually not making hot water. Right? So the best way to do that's, just go to the water heater. You can touch the relief valve.
Okay.
See if it's hot or cold. Because if the relief valve's hot and you have cold water coming from your faucet, that's going to be a plumbing issue.
Right.
It's going to be something, we're not really even going to be involved in. But, of course, if you have no hot water coming out and you touch that, it's cold. Next thing I would check would be the electronic gas valve to see if I have a status light.
Okay, so I'm going to go to the heater, I'm going to look, and I'm going to see if I have a status light. If I don't, obviously, I'm going to try to relight it.
Correct. So if you do not have a status light, that means the heater's off. If you do have a status light, just, look at the sticker, see what the code says, refer to the manual, follow that code.
Okay.
Right? But the most common, like you said, is going to be no status light.
All right, so I'm going to go to the heater. I'm going to try to relight the heater. Now, this is, again, this is an electronic gas valve. It's going to take a little bit longer than a standard, the mechanical style. So it can take up to 90 seconds to light this heater because of that thermopile.
Yes.
So let's say I'm trying it, but I'm never getting a status light. I mean, I just can't get it to light.
Well, to get a status light, we have to have air, fuel, and spark, all in the same place.
Okay.
Right? And so, we're always going to have enough air just for a pilot flame.
Okay.
Right? No matter what you do, you're always going to have that. So, we're looking at fuel or spark.
Okay.
Right? So, if it's not lighting, if you're never getting a status light, then I'd recommend actually taking off the outer door, looking in the sight glass, and seeing what you really have going down on the inside.
All right, so I can remove the sight glass, remove the outer door, and our sight glass is right there.
Correct. And you would want to look inside and up to see what you have, because you should be able to see a spark, right? As you click the igniter button, you should see the spark. Now, it may be necessarily to dim the room lights or, something along that if it's a brightly lit room. But, typically, it's two things that we need for it.
Now, what if the spark is not? I can't see a spark. What if I don't know if my spark is actually working?
If we don't see a spark on the inside, that doesn't necessarily mean we don't have a spark. You just may not be able to see it because it's just a tiny spark, and you have to look in the exact right area to see it.
Right.
But you can pretty much test the spark,
Okay.
which is fairly simple. And so what I'd want to do to test a spark igniter to see if it's working, you see I have this white connector here, an
Okay.
orange wire that plugs into it. That's my spark igniter and the spark wire for the electrode on the inside. Just simply want to unplug it. And typically what you do is just hold this white connector close to something metal and click the button and see if it generates a spark, right? Now, when you do that, usually one of three things is going to happen. Either nothing's going to happen, which typically means the spark igniter's not working, or you're going to get a spark, right? You'll visibly see it, or you're going to get shocked,
Right.
which means 2 out of those 3 things means it's working. Right? If you see the spark or get shocked, the spark igniter's working.
Okay.
Now, it is possible for you to have you could have had a loose connection, and so by unplugging it and replugging it in, that's all it needed. Now it may actually generate a spark on the inside.
Okay.
And so that, I mean, it's rare for a spark igniter to ever fail.
So let's say, let's back up a little bit. Now, let's say we go ahead and we hook our spark igniter back up. We light it, and it actually does light. And then, it goes out from time to time. I mean, because this can happen in this heater. But there's not getting any code. We're just having we have no hot water. That's how we know. We have to come back and light it. And every so often we're having to do that. That's one of the calls we get on this heater, isn't it?
Correct. If you constantly get to where it relights, but then it goes out, there's a couple of different things that could cause that.
Okay.
Right. One of the more common things that we see is that they have a shorter vent run and they didn't actually use the restrictor.
Okay.
That's on it. So what happens if you're not using that restrictor is this thing drafts pretty strong. It has really high flue temps.
Right.
Right. And so what can happen is that flame actually lifts off the burner because we're moving too much air and it just sucks the pilot light out.
Okay.
That's one reason. And a couple other reasons, high wind. These do vent out of a sidewall, right, typically. So if you're terminating on the wall with the prevailing winds, and since it's, all sealed vent system, wind could, it's a possibility that comes in, shoots down, and actually blows the pilot flame out.
Okay.
Right, so that's something you would notice. You would only notice that on windy days.
What is it? Moving the vent, would that work? I mean, is there something that they can do to help with that?
Well, it all depends on the installation,
Okay.
right? I mean, every installation can be unique to what you need to do to prevent that. Another thing that you actually see sometimes with this, if the installer's a little rough on that corrugated vent pipe, where they install it, you can actually damage the inside pipe.
Okay.
Right, which causes recirculation of the flue gases.
Inside, yeah.
Yeah, they cause it inside, which you can usually tell to have a yellowish flame.
Okay.
Because, as that exhaust is trying to escape, you've used most of the oxygen in it. And so if it starts sucking that back in on the intake and it doesn't have a lot of oxygen, it's not going to burn properly and
Right.
it'll kind of smother itself out.
Okay, so that's if you have no hot water, you relight it, it works, and then a couple days later you have no hot water again. You might run into a situation like that from time to time, and that's when you're looking at the venting. Really, installation is what you're talking about.
Correct, installation. So there's some tips there you want to keep, in mind for installation.
All right, so now let's get back to, so I'm trying to light this, all right? I have no hot water. I come up there. I have no status light, so I'm holding the knob down. I'm following my lighting instructions that are on the side of the water heater, how to light the pilot, and I'm clicking this button. And this water heater is designed to where I really don't have to look down through the sight glass at first. I'm just looking for the status light. But if I'm trying, and I've been doing this for over 90 seconds, and I've done this a few times, then I'm going to have to take my door off, and I'm going to have to look through this sight glass. Well, I'm sitting there trying. I'm looking through the sight glass, and I still don't see a pilot. I mean, I see a spark. I know I got a spark, but I don't have a pilot. Where am I going with that?
Well, if you have a spark, but you're no longer, you're not getting a pilot, it really only leaves one of the, 3 things that are missing out,
Right.
and that's going to be gas.
Okay, gas.
Right, this is gas water here, we must have gas.
Okay.
And it's pretty common on a new installation that you're going to get air in the gas line.
Right.
And so it may take multiple lighting attempts to try to get this heater to light.
Okay.
I've seen it take, 3 or 4 times,
Okay.
or even more sometimes, depending on how far away the shutoff valve is, whether or not they've bled the gas line at the sediment trap.
Yeah,
or
and
gas line at
that
the
pilot
heater.
orifice is teeny tiny.
Yeah, and so it's going to take a long time to push all that air out.
Okay.
Right, and so we want to, make sure that happens. Or, if it's a water heater's run for a while and you had an interruption in gas service to your home, you don't know how much air, is in that gas line. So it may take multiple lighting attempts,
Okay, all right. So If I can't get it to light, I don't see a pilot, then I'm going to go down my gas road.
Yeah.
And it could be a shutoff valve, it could be air in the gas line, but it's something on the gas side. If you have, because you know you've got enough air in there and you've got spark, it's something on that gas side. But let's say I'm holding this down, I'm looking through the sight glass, I do have a pilot, but every time I release the knob, it goes out, and I'm never getting a status light.
Correct. Now with this heater, we do want to make sure, since we're using a thermopile, that we're actually holding in the knob long enough.
Okay.
And so we do want to make sure once it lights, we hold in the knob at least 90 seconds.
And you got to have a really good grip on this, because even if you move your thumb sometimes, it could go out.
Yeah.
So really hold on this this knob and make sure you keep it on, okay?
But if we're getting the pilot flame, we're holding in the knob a good amount of time.
Mm-hmm.
And then we never get a status light, or we let go and it goes out. That typically means we have some type of electronic problem.
Okay.
Either we're not generating the millivolts, where the thermopile plugs into the gas valve could have a loose connection, or a marginal connection,
Okay.
or something's wrong with the computer or the gas control valve.
Okay,
on the
so
water heater.
what would I do? What would I do first on a situation like that?
Well, typically the easiest thing to do is going to be actually just check the thermopile.
Okay.
So we want to use a multimeter.
Okay.
That's something we're going to need tools with. Set it for DC millivolts and test the thermopile. Now thermopiles, where they plug into the gas valve, typically have a little door. So you can hold that. They typically have a door. You have the two wires, right? So you want to open that little door on the back side, expose the back of the flag connectors where it plugs into the gas valve, and just stick one lead on each of the wires.
So you're saying this for millivolts DC on our meter?
Correct. And so what we'll do is stick the leads there, but we're going to have to light the pilot light.
Okay.
And we're going to have to hold in the knob, the whole time, since it's not holding. And what we want to see is at least 350 millivolts within 90 seconds, right? That's what the requirement for it. So that means you're going to have to hold in the knob. You may actually need 3 arms to do it, or a helper someone to help you. Opening the back side of that thermopile connector, you can just kind of stick the leads in there and not damage the connectors.
Okay.
If you unplug the connector from the gas valve, you can test it the same way, but you don't want to just jam your leads in there.
Yeah.
Because it'll stretch out the flag terminals. So
Right.
that's why I recommend checking on the back side.
And
That
then
way
you
we
have
don't
it
damage
plugged in like it would be in a real world situation.
Correct.
So it's actually plugged into the gas valve, so we can really see what that thermopile is generating.
Correct. And so like I said, the requirement's going to be 350 millivolts within 90 seconds.
Okay.
If we're not getting 350 millivolts within 90 seconds, that's typically going to be an issue with the thermopile.
And then we just replace the thermopile?
Correct. You'd replace the thermopile.
And you can
and
follow the owner's manual on that. It walks you through replacing the thermopile. Also, if we do have 350 millivolts, actually, it's not just going to say 350 when you're doing the test.
Yeah, as you test it, as that
Yeah.
pilot light heats that thermopile, it's going to climb.
Right.
So that's why we want to make sure we give it at least 90 seconds to reach that point.
Okay.
Right. So after 90 seconds, you should, of the pilot, heating the thermopile, we should have around 350 millivolts or more.
Yeah, you may see upwards of 600, 700 millivolts in that type, especially if it's new. You're going to see it pretty high.
Yeah,
the longer it runs, yeah.
Yeah, the more the better.
Yeah.
I mean, that's so the threshold's the 350 millivolts. Less, you need a new thermopile.
Okay.
If it's 350 millivolts and up, we're getting, the thermopile's good.
Okay.
Which means we're going to have an issue with most likely the gas control valve.
Okay.
Either something in it has failed, it's non-serviceable, you have to replace the whole gas valve.
But make sure your connections are good in that situation. Unplug it, plug it back in. Make sure that you have a good connection on the gas valve before we actually, determine that it is a gas valve, because that's not a very common thing that we get calls on.
Correct.
Is it actually being a gas valve?
Correct.
All right, so that's no hot water. Really, what we're going to do is try to relight the pilot. If we do light it, and it works for a few days and it goes out again, we need to check the installation, check the venting. If we're trying to light it and we don't get a pilot and we do have a spark, go down the gas road. Make sure you have gas coming to the water heater. You don't have a shutoff valve off, air in the gas line. But if we're trying to light it and we do get a pilot, but every time we release the knob it goes out and we never get a status code, we go down the electric road. We're going to go take a look at the thermopile. Check the thermopile for millivolts, 350 and up. If you have it, then, if you don't have 350 millivolts when you do that test, then it's the thermopile. If you do have it and all your connections are good, it could has to be the gas valve in that situation.
Yeah, that's the only other part. So, I mean, if the pilot's not holding, you have the thermopile making power, where the thermopile plugs into the gas valve and then the gas valve, right? So one of those three things, if the pilot's going out as soon as the knob's released, or you're not getting a status light. It's possible you get a status light and that goes out as soon as you let go of the knob because an electromagnet or something has failed in the valve. But, I mean, either way, as long as your thermopile's good and it's plugged in,
Right.
the only thing after that would be the gas valve. You know,
Alright.
so, I mean, most likely it's always usually going to be a thermopile.
Right.
You know, that's what you mainly see is just thermopiles failed.
Yeah, because that's the most common thing.
Correct.
All right, that's a look at the atmospheric direct vent water heater.